Hey guys, and welcome back to Dan's Pro Shop. Today's episode, we're heating things up, if you will. I got myself here a 7500 watt, 240 volt electric heater that we are putting right over there. Now, I know a lot of you, hey Dan, natural gas, why don't you use heating oil? I see you have a pellet stove, why don't you just use that? Hey guy, come on. I wanted some kind of supplemental source, something that I can just keep it 40 or 45, maybe even 50 degrees in here all of the time. So whenever I come out here and it's like -10 outside, I don't have to get the garage up from -10. We're already hovering at 45. Then I kick on the pellet stove and get it up to operating temp, if you will. But either way, hopefully this should be relatively straightforward. The plan is, got some SOOW here, I'm gonna slap an end on it, use the same outlet that I do for the welder, and yeah, we're just gonna get into it. Well, I suppose a solid step one would be just opening this thing to see what we got. Now guys, bear in mind, this isn't a sponsored item, no promotion, no nothing. I bought this here electric heater with my good old American dollars off of ye old Amazon. I'm sure the thing isn't American, but the money was. So this is a Comfort Zone Industrial 7500 watt, 240 volt heater. So, come on now. In case you guys are thinking about doing this project for yourself, bear in mind, you need 240 volts. And let's be honest, electric heaters aren't the most efficient thing in the world. That being said, they may be costly because they consume a lot of amperage. But as far as efficiency goes, electric heaters are actually 100% efficient. Now that meaning, all right, let's just say you're using a torpedo heater with diesel fuel, right? You put in 1 gallon of diesel fuel and you get out 160,000 BTU. All right, whatever that conversion is. There is some energy loss. There is thermal loss between the energy potential of the fuel and the actual heat that you get out of the end. So yeah, you're getting a lot of heat, you're getting it quick, and the fuel is cheap, dare I say, but there is a loss. There is not 100% transfer of the energy from the fuel to the energy of the heat you get out. With electric, 100% of the electricity you put into it, you receive back in form of heat. Well, I mean, this one, it has a fan on it for forced air. So if you want to get picky, there is some loss in the fan. But either way, electric heaters and furnaces are 100% efficient. And not to mention that you do not have to exhaust an electric heater. That's another thing. I wanted this project to kind of be quick because we're kind of over the hump here in wintertime. And it's just, yeah, I wanted something to be quick, dirty, and easy. And natural gas, I'd have to dig a ditch in the yard and run a line, and anything else you would have to exhaust. So I'd have to blast a hole in the side of the garage or go through the roof, or ain't no way I got time for that.
Ain't nobody got time for that.
So we're going electric. And for the little amount that I plan on using it, I think this is going to be the ticket. That's nice styrofoam bubbles everywhere. All right, let's do this again. Oh boy, this is a cute little thing. I tell you, I was reading the dimensions online, and it's like, oh, okay, just reading numbers is one thing. Actually picking it up, holding it in your hands, is a totally different thing. So first thing I noticed right off the bat, definitely not the color I ordered. I ordered a black one. But whatever. This isn't a beauty contest. This is a how can we heat the garage up contest. So this particular one, in case you guys are thumbing for a part number here, it is Charlie Zulu 230 Echo Romeo - Echo Charlie. And this is the Comfort Zone 7500 watt. They have a 5000 watt and also a 10,000 watt. This is the Goldilocks right in the middle. And in case you guys are unfamiliar with Ohm's law, 7,500 watts divided by 240 volts means that we're running roughly 31 amps. And the circuit that I plan on putting it on is a 50 amp, 240 volt circuit. So we are really good. I got plenty of overhead. There shouldn't be an issue with overcurrent this thing, but I'm trying to help the pocketbook a little bit and not go for the tippy top. Either way, from the bottom to the top, 13 inches, width is 14 inches, depth is 11 inches, and there is a bracket that goes over this thing, so either you can hang it on the wall or from the ceiling like I plan on doing. You guys can see these brass inserts here. That is so you can angle this thing from the ceiling bracket. So I guess let's do a little bit of assembly, figure out where this thing is going. I'm pretty sure that I'm gonna have to add like a 2x6 or something in the ceiling, you know, in between the joists just to sure it up. But yeah, let me throw this thing together and we'll get into it. So here we are in the business end of this old girl. Here is that bracket that I was telling you guys about. It just goes underneath these thumb screws on either side, and then it indexes with one of these top ones so you can angle your dangle, if you will. And the thing that sold me on this particular one, for the price tag, I think this was like 160 bucks. But what sold me on it is this thing has an internal thermostat. I know that these cheaper ones notoriously have a terrible integrated thermostat. But honestly, even if it fluctuates 5-10 degrees, that's going to be good enough for what I'm shooting for. But the cool thing is also, since I plan on hanging this thing from the ceiling, it comes with a remote. Super easy. On, off, temperature up, down. That's really all you need. I mean, like I said, I plan on just running this at a low temperature, 45, 50 degrees, then crank it up whenever I come in here, or just leave it at that low set point. That way, the pellet stove doesn't have to work so hard for so long to get it up to a comfortable temperature in the garage. So now that we have this thing out here, I suppose the feasible next step would be to terminate some wire. Now, I got myself here some 10-3 with ground. Anybody that knows anything about wiring be like, hey, Dan, 10-3, that is a 3-phase 480 wire. Well, yeah, that's not what we're using this for, but this is what I had left over from a project. So it's cool that it's 10 gauge, so it's more than big enough on AWG to handle the 30 amp load for this thing. And so we'll just have an extra conductor in the cable, whatever. I have it. I didn't have to go buy any more. So what we're going to do here is I got myself a 50 amp, 125 volt plug that's the same as my welder. So it's going to go right into the same thing. This isn't the standard typical 240 volt welder plug. I jacked mine up to a 50 because that is the circuit for the 240 volt in my garage. So I wanted everything that I plug into it to have the ability to tap into that 50 amp circuit, if you will. I mean, it's just, there's no such thing as oversizing whenever you come into wire. Then I got me some dumb stuff here, some conduit straps so we can put this SO on the wall, and some 3/4 inch KOs. I wasn't sure if this thing had a cord grip in it, so I just picked these up. These are like $2 at your local hardware store. So why not? But either way, we're going to go ahead and strip this thing. At least put, I don't know, we'll probably terminate this thing into the heater first, and then we'll do the plug once it's hanging and we know how long this needs to be. So guys, my suspicions were correct. I don't know if you can see this from there, but there are 2 KOs in the side of this thing. Just happens to be a trade size 1/2 inch and a trade size 3/4. Looks like I nailed it. And because of the size of the SO I got, I needed a 3/4 inch knockout with a cord grip anyway, so that'll work out just fine. And from what it looks like, this bottom panel comes off just like most electric heaters. And I'm betting that the start and the relay and everything is going to be in here along with the bus where we tap into the terminal strip. So let me get this thing apart and I'll show you what's in the inside. Could I read the instructions and find out all this stuff before we start? Yeah, I could. But, you know, I've done this kind of stuff a time or two, so I feel pretty confident I know what's going on. Well, look at that. Some PCBs, line 1, line 2 terminal contact, some relays. We got one for the fan, one for the heaters, and then we got some other stuff going on here. Some capacitors. I'm guessing the gigawatts for the thermostat. We got an overheat protection in there. So yeah, let's knock out that knockout and terminate some wire. Now guys, apologies if I'm kind of like ripping through the terminology here, but this is what I do. And if you're similar to the field, you know what I'm talking about. When I say KO, that means knock out. And that is a trade thing. And whenever I mentioned trade size, 1/2 inch and 3/4, that means if you pull a tape across this, this is not 1/2 inch. This is not 3/4. That means that this 3/4 trade size is the size of the knockout for a 3/4 inch piece of conduit or 3/4 inch cord grips, just whatever. That doesn't necessarily mean that the plug, the hole is 3/4 of an inch. This is just one of those nuanced things that you get from being in the industry and you kind of just know. Either way, the best darn tool that any Sparky could have is these Klein Journeyman Series crimpers slash nippers, because that's quite literally, I've never met a Sparky that hasn't done that with either lineman pliers or these particular pliers. That's just what you do. You pound on that knockout until it comes out. So you just wiggle this thing back and forth until it snaps, and then we'll put our cord grip in. Just like so. Now, in case you guys have never seen a cord grip before, this is what I'm talking about. It just has a threaded end with a collar that locks on the inside of whatever you're connecting to. And then this bottom part of the saddle is fixed, like it's part of the unit. And then this top part simply gets tightened down with these 2 machine screws. So this clamps down onto the insulating jacket on the wire and holds everything in place. So that way, if the wire gets yanked, it doesn't rip itself out of the terminals in whatever you're fixturing it to. So this is a really big integral part of anything electric. So we'll go ahead and throw this guy in here. Simply put it in, tighten it down. I'll bring you guys in so you can see what I'm looking at whenever we get there. Again, with the crimpers here, everybody does it. If a Sparky tells you he doesn't do this, he's lying to you. I'm telling you, everything is a hammer when you're an electrician, especially lineman pliers. So another thing to keep in mind whenever you're installing a cord grip is keep in mind the orientation of the screws. Make sure that you can get to them whenever this thing is fixtured where it's going. So since this thing is upside down right now, and it's going to be like this in the ceiling, this way I can reach it with my multi-tool whenever it's up there and tighten this thing. I guess it really doesn't matter right now because we're installing it now, but either way, this is nicer egress now. So guys, this is what the guts here look like. This is the cord grip that we just installed. This is the chassis ground, or I'm sorry, I come from an automotive background. This is the equipment ground. This is where our ground will go. And then line 1 and line 2. Because this is a single phase 240 volt circuit, we just have 2 legs of 120 volts. And that's coming from the entire secondary side of the transformer outside. Actually, I've talked about this before in case you guys are unaware of how transformers work, and that's why there's no such thing as 2-phase. That dives deep into the theory of electric, but either way, this uses both buses in the panel in the house to utilize the entire secondary coil, so we get all the gigawatts we can from the pole outside. So, next step here, we'll open up this cord grip, give us plenty of room to get our stuff in there. Maybe. There you go. Do yourself a solid and pass this thing through the cord grip before you strip the jacket. It just makes your life so much better than trying to fish all those different conductors through there. Once you get a good amount out here, now we can strip this back and terminate the ends. So I'm going to use my surgical tools here, my Klein banana cutters, and oh so delicately remove the outer insulating jacket on this here. This is another thing Sparkies will do, I'm telling you. There are specific wire strippers for this, and actually, I have them, but they're just at work right now. So, you can either do this or use a razor blade, whatever. You just got to be delicate and make sure that you don't get into the conductor on the inside. So do a little bit at a time, bend it, a little bit at a time, bend it. You'll see whenever you get far enough because it kind of like cracks open and you know where that is. So you guys can see here we got 4 conductors coming out of this thing, which we only need 3 since we're using single phase 240 volt. I need the green conductor for the ground pin, and we're going to use the black and red for our line 1 and line 2. And we're just going to cut off the white one because for this application, it's not needed. I'll go ahead and trim all this stuff up, get all this unnecessary crap out of the road. Like I said, we'll cut that white one off, get all this paper insulation out of the way. Now for this particular process, these leads don't need to be very long, but give yourself enough room to work in here. Okay, my bad, fellas. I just noticed that the equipment ground is a little bit further away from the terminal lugs than I thought. So I simply just strip back another 2 inches or so. That will give me plenty enough lead on this green ground conductor to get where I need to go inside of here. And then for the line 1 and line 2, I can simply just trim those down into where we need to go. So, like I mentioned, this white conductor that we're not needing, simply get that out of the way because it's just going to be taking up space in here for no reason. Now, we can back this up to an appropriate location, make sure all of our wires get to where they need to go, and yeah, that will work just fine. Now, we can strip these wires back. I'd say about 3/4 of an inch or so because of this gauge. Now, I don't know particularly what they recommend for wire size here, but hey, look at that. It even says here, max heater current 31 amps. It's almost like Dan did his math. So, yeah, I don't know what size wire they recommend, but bigger is always better when it comes to wire gauge. So 10 gauge, I feel safe running this because the whole point of the size of a wire, like think about this like a garden hose. The bigger the hose is, the more water can run through it at one time. Wire is very similar. The bigger the wire is, the more current can go through it with less impedance. So the less resistance there is, the better it flows and the less it will heat up. That is the stuff that causes electrical fires in homes. You know, like when you're trying to run a refrigerator off of like a string of Christmas lights, you're pulling a lot of juice through a wee little wire and that thing gets hot like right now. And that's the stuff that will bring down houses. So I think because of what's going on in here, you see the terminal lugs for line 1 and line 2 and this equipment ground. I'm going to put a ring terminal on the ground one, and I'm going to put some ferrules on these guys here because these lugs are a little big for just regular old stranded wire. And if you've ever done this before, whenever you tighten a lug down onto stranded, it kind of like flares out. Well, I want to make this the best connection I can because this is another big thing where resistance comes in. If you do not have a good, solid, tight connection, the resistance goes through the roof on that connection. Like, I don't know if you guys have been exposed to this before, but I've done a couple jobs where like you open a panel or a disconnect or something, that joint or that connection, you can see them glowing because of how hot they are because of the resistance and the current running through that thing. So either way, we're going to put some terminal ends on here, a ring for the ground and some ferrules on the other two. So I got myself a 10 gauge ring terminal there for the ground and a handy dandy little ferrule crimp kit. Don't worry, if you guys are interested, I will link all of this stuff in the description below. And that off chance that you guys are doing the exact same project that I am, or maybe this is just giving you ambition to do your own project. So we'll go ahead and pick an applicable ferrule here. And it appears to be the biggest one in the kit is 10 AWG. And that means American wire gauge, in case you guys didn't know. Go ahead, pop these guys open and give her a crimp. Oh yeah, that's nice. So just in case you guys want to get a better look at how that works, this is the stranded piece of wire beforehand. This is what would have gone into this terminal block. We take a ferrule. It's got this nice little plastic beauty cap that goes down over the insulating jacket of the wire. We take our crimper, go down over the entire conductive surface, make sure it's in there, and we crimp. And this beautiful little thing is what we're left with. That way, whenever you crimp this thing down into the terminal block, those wires stay together and we are ensured a good connection. Now with this equipment ground, it's a little more crude. We simply put this ring lug on here, and we're going to take our previously used hammer and just crimp the bejesus out of it. This one isn't as critical because it's an equipment ground. Now, don't get me wrong, grounds are important. This keeps you from getting zapped if one of these touch something metallic in here. But, you know, it's either way. It's a good thing to do it right whenever you're doing it. So now that we have the wire all prepped, ready to go, we can pull this thing back, give us some room, terminate them where they need to go, and then tighten up this cord grip. So first things first, we might as well go ahead and terminate our line 1 and 2. Now, in case you guys are wondering, hey Dan, how do you know which one goes where? Which one's line 1 and which one's line 2? It doesn't matter. Pick one, anyone. Because we're supplying 120 volts to either side of this, it doesn't bloody matter which one is which. And whenever you get into 3-phase bigger stuff, it kind of matters even less. Because they're all really the same, the only thing that changes is rotation. So yes, that's how you're able to change the rotation on 3-phase motors. But either way, like I said, we're digging deep into electrical theory. That's kind of not the point of this video. But whenever you're putting this thing together, just pick a spot and put them in. Make sure they are good and tight. Now, don't go so tight that you break or strip the terminal here. But make sure that it's almost like on the verge of uncomfortably tight. Once that thing's in there, now we can loosen up our other equipment grounding lug. Maybe if I had the right tip, there you go. There's a little star washer under here. We'll go ahead, put this all together. Put a nice little service loop in there for stress relief. There we go. Tighten this thing down good. There we go. Now we are grounded. Yeah, not the bad kind of grounded either, the good kind of grounded. And we can tighten up our cord grip. Oh, looks like I got to do some more banging on this cord grip, get her tighter. All right, just so you guys can get a better little look-see of what's going on here. I simply took line 1 and line 2 and terminated them where they go in the strip. And our equipment ground here goes right, this is the factory one that everything else is connected to. It goes through the chassis or the equipment, and then our ground goes to this other one. We have enough cord here for enough stress relief. Nothing's tight. It's all good to go. And we have our cord grip attached and everything is good to go. Now we can put this bottom back on. So now that I just stacked all my crap on top of this thing. Oh, in case you guys are wondering, there is a wiring diagram on this thing too. So it tells you the wattage of the heater elements inside of it and what's going on. Like we have the over temp switch, ambient temperature thermostat. We got our motor, the relay control coil, and the line 1-2 switch. But yeah, so pretty straightforward stuff. Either way, we will put the cover back on, fasten her down, after I find the screws that I lost. Yeah, I'll get back to you on that. Oh! Cool, everything's back on, safe. Our wire is terminated. So, hopefully the more difficult part of this is over. And now we just got to hang this thing in the ceiling. But like I mentioned, I might have to add some timber in the ceiling because I'm not quite sure what's going on over there. But either way, we'll figure it out and I'll show you where it's going. Boy, I tell you what, it's like darn near a beautiful day here in Western PA. It's like dangerously close to motorcycle weather. Actually, I've heard quite a few of them rip up and down a road out here. But we got a project going on. So the goal is I want to put it right about here because the outlet for my welder is right there. So minimum cord, right? Hopefully I have some left over for the next project. But you guys can see this light bulb, perhaps. That is on a ceiling joist right here. It sticks out a little bit further than I would want, and it may be in front of the hose reel a little bit. But for sake of simplicity here, I just want to get this thing up and running. Like over the summertime, I can get up there and put some lumber in and put this thing actually where I want it to go. But if you guys are familiar with roofs and attics, if you've ever been in one, the closer you get to the eave, the less you fit. And I know from experience from wiring this outlet, this corner is absolutely bloody miserable for my 220-pound dad bod to get into. So, for simplicity's sake here, and just to get this project rolling, we are going to put this guy right there, and then that'll give us enough angle, and then I can point it down and everything, and that's just a good area for the garage. So, I think I'm going to get myself up there with a lag bolt, sink one right in the middle there so we get some pivot action, because this thing doesn't weigh much. I mean, the whole thing is maybe 8 pounds, 10, let's just say 10 pounds rounding up. Put a 3/8 lag through here with a fender washer. That'll be more than enough. Well, look at that. 3/8 by 1.5 inch lag bolt. And a fender washer. It's almost like we knew this project was happening. So that thing should be plenty enough to hold this thing. That'll sink 1 inch into the joist, and that's more than enough for 10 pounds. Let's do it. Let's see what we can do about getting on up there. Yeah. We're going to do this 100% the right way and just feel through the ceiling. I'm going to start the bolt first, just so I don't have to deal with the dumb bracket. Maybe. Oh yeah, there's solid lumber there. Oh yeah. Yeah. It'll break the bracket before it comes loose. That's plenty good enough. So now let's take this old girl here. I'm telling you, man, the wire weighs more than this thing does. Got the thumb screws. Got one started. Come on. There we go. There's two. Now, we get to pick our angle. And I think I'm going to go for the middle slot. Seems to be a happy middle. Oh, and don't worry, I'll bring you guys up here and show you all this once ever I'm done with my stupid fat head in the way. Nice. I'm telling you guys, if you're like genuinely worried about this thing hanging on one screw, I wouldn't be. I'm telling you, it may be wiggly, but there's no way it's coming down. Well, let's take this out of here before we forget about it. Lord knows we don't want to leave that in there. Nice. Now let's do some cable management. I'm going to use these fancy conduit straps that I showed you guys earlier. And trust me, we're not show stopping with pretty here. We're just going for effective. So make sure we leave plenty of room here for the cord. We don't want anything to get pinched or in the wrong way. That'll work. I'll keep on moving down the line. There you go. Nice. Good. Run this down a wall and into where we're going with the plug. So I mentioned I was going to cut off the extra, but I mean, it's like 2-3 feet of extra. So I'm just going to leave it long because I mean, whatever. If I end up moving this thing, it'll be nice to have that extra couple feet on there. But either way, we're going to do a very similar thing here. Strip back about 4 inches or so. You can always take the extra. Be super careful when you're cutting your jacket so you don't nick the inside conductors. This is just one of those feel things that you get after doing it for a while. Like I mentioned, they do have a proper tool for doing this, which I'll link that in the description, as well as these banana cutters because they're freaking awesome. But very similar thing here. Cut off all the extras that we ain't using. All the insulators, this white conductor, because we're not using it. So let's just cut it off and get it out of the way. Cut off all this other garbage. And then we'll start assembling our 50 amp plug. So in case you guys have never done this before, most of these larger plugs are kind of like build your own. You know, it's per situation, it's suited to you. So for this particular one, we need a 50 amp configuration on a 120 volt circuit. So these come with multiple different like tangs that go into here that index with the outlet that you're using. So obviously you need to make sure that you buy the correct plug for what you're doing. And then you also need to make sure that not only the plug, but the components that go into it are correct. So I'm going to go ahead and wire this thing together and then show you guys what it all looks like when it's done. So here I have all of my prongs wired up for the plug. Hopefully you guys can see this. I know it's bright over here. But I simply strip the wires down to the appropriate size for how it receives into the plug. Hopefully you can see that, the ground and then the 2 lines down here. So you're going to have to cut these and strip these to an appropriate length. Once you have everything where it needs to go, you can simply put these things in here and then close this up like a clamshell and bolt everything together. We'll go ahead and feed these prongs through the holes in the plug one at a time. Get everything good and in there. Nice. Now that everything is home and seated just like it should be, see how I cut these short enough that the jacket is actually inside of the plug? That's what we're looking for. So this thing actually has some cord grip capability. Now that being said, do not forget to install this little cord grip thing inside the plug. This is what actually smushes onto the jacket of the wire and keeps this thing. It's just like the cord grip that we did on the heater. Now, once everything is all put together, use the screws supplied in the kit, clamp everything down. Awesome. Now that everything's tight and secure, our connections are done. So the next step is I'm going to go shut off the breaker for this outlet before we plug it in. That way, whenever I spark this thing up for the first time, I am well away from it. So this guy right here, 50 amp breaker, we got it off. Now I know that receptacle is dead. I can go ahead and put this in where it needs to go, and we can try it out. Get that plug out of the way. Plug our heater in. Now I know it doesn't look pretty, but hey man, it's a garage install. We're worried about heat, not presentation. So here goes nothing. We're all plugged in. You know what they say, hold an ear, pop a breaker. We got a beep. It's on. Nothing's happening yet, but we have power. It's on. Now let me grab the remote and start playing with it. Of course, those cheap SOBs don't give you no batteries in the remote. Why would they, you know? Pop them in there, maybe. Come on, this shouldn't be the hard part of this project. There's one. Nice. Let's see what it's got. Oh, she turned on. I heard it click. And we're running. Oh, that's nice. digital thermostat and red LCD that you can actually see from across the shop. So let me take you guys in a little bit so you can see the display. So I don't know if you guys can hear that thing very well, but honestly, it's super quiet for what it is. And it's super simple to operate. On the remote here is just on off mode for high and low. I'm guessing that's for fan. Yeah, I got no clue what that means. Then temperature, up, down. So you see right here, I'm setting my set point to 63 degrees Fahrenheit. And you have a timer button so you can set this to shut off after so long. And you can switch the value between Fahrenheit and Celsius. So super user friendly. So guys, throughout further investigation, I found out that this mode button here changes the amount of heater elements that are on inside of that. So I think the electrical diagram said that there's 6 in there. So this mode either turns on 3 of them or all of them. So you can be a little more energy efficient if you would like to be. Or if you want to get this thing hot quick, you put it on high. So I'm going to set this thing to 45 degrees. Let's just say 50 degrees on low. So we can have like a slow boil, like a crock pot. So hopefully this thing will keep the chill out of the garage. And whenever it's -10 outside, it's not going to be -10 in here whenever I come in here and then take 3 hours for the stove to heat up. I mean, like I mentioned, the stove is awesome and that thing will make it 200 freaking degrees in here. But it takes a long time to get to that temperature. So hopefully this thing will just make it a little more easy and user friendly to be out here. So hopefully you guys like this quick little project. And like I mentioned, it's not a beauty contest. I know it doesn't look good and it's not exactly in the spot where it's supposed to be yet. But you guys saw this in pretty much real time, out of the box, on the ceiling, wired in. So, I mean, with a little bit of know-how and let's just say under 200 bucks, I got a good thermostatically remote controlled 240 volt heater in the garage ready to go. So whether you're hanging out in the basement or the garage or just something that you need a little more climate control in, this guy might just be the ticket for you. So like I mentioned, if you're interested, I will link all this crap in the description. The tools, the parts, the heater itself, some wire, some plugs, and yada, yada, yada. But you guys can check this out for yourself if you're interested in doing it. So hopefully you enjoyed, and we'll see you next time.